Example 1 on page 624, graph this f of x equal to x squared. Now, solution. I want you to remember this. When you see an equation f of x equal to x squared, think about this shape, okay? It looks like V shape, but it's not steep or sharp as V, okay? It's rounder, okay? It's like half of the ellipse. When you see f of x equal to negative, let's see, did I get up to that? Yep. So when you see f of x equal to negative x squared, you will have this graph, it flipped the other way around. This is open up, this is open down when you have negative coefficient of x squared. Okay, so positive coefficient of x squared, open up, negative coefficient of x squared, it flip the other way around. Open up, open down. So for this case, we have f of x equal to x squared is going to open up. To graph this, you know the shape when you see this. Just for accuracy, just use a couple of points. How about -2, -1, 0, 1, 2? Let's use 5 points. When x equal to -2, okay, x equal to -2. -2 squared is 4. Okay? And then it turns out, because this is x squared, right? When you have 2, you will have the same result. When you square it, it will equal to 4 as well. So in a sense, when you see this, x squared, these two x right here, when you calculate, you can actually calculate at the same time plus or minus 1. Because substituting plus or minus 1 as x squared, you get the same result, which is 1. Okay, true for x squared, the graph of a parabola. So when x goes to 0, 0 squared equal to 0. So 0 here. Okay? So we're ready to graph. X, y, so 0 here. When x equals to -2, we have y equal 4, so 1, 2, 3, 4. When x equals to -2, you go left 2 units, and the corresponding y is 4. Positive, you go up 4 units, so somewhere here. And we can label the points, point A, point B, point C, point D, point E. Okay, we can label this point as A. So the first one is A. Next one we have -1, 1. So -1 for x. From the origin, you go left 1 unit. And then for y, it's positive, you go up 1 unit. So -1, 1, somewhere here. And this is point B. And point C, you have 0, 0, which is right at the origin, where both x and y go 0. So this is C. Okay, and then D is 1, 1. So because 1, for the x positive, from the origin you go right 1 unit, and for y you go 1. From the corresponding x go 1, you go up 1 unit because positive. So this is 1 here. So this point right here is D, and the last one is equal to 4. So x equal 2, positive. So you go to the right 2 units from the origin, 1, 2. So 2 here for x, and 4 positive. You go up 4 units for the y. So somewhere here, 1, 2, 3, 4. So this point right here is E. And you already know that when you see x squared positive, that means the curve will open up. So connecting all these points, you kind of see the patterns, right? So connecting all these points, and connecting all these 5 points, I have the graph of the parabola. Okay, as you see, it's open up. So this is the graph of f of x equal to x squared. Now, I want you to also think about this too. So here another case. So if you have f of x equal to some constant here, for this case constant is 1. Okay, a is 1. If you have 1/2 x squared, this 1/2 right here is less than 1 over here, okay, the coefficient. This would make the parabola fatter. So suppose this is the graph of f of x equal to x squared. Okay, if you have another graph, that's called g of x is equal to 1/2 x squared, where the coefficient 1/2 is smaller than this. If you have this, when you graph this, the parabola will be fatter. Okay, it's still open up, but it's fatter compared to this one. You see, it's wider. So, suppose you have h of x, another graph. Now this time you have 2 times x squared. So twice this x squared, because the coefficient now is 2 versus 1. Not only that, this coefficient is also more than this, 1 or 2. You graph this, it turns out the graph will be a skinny parabola, which is, okay, skinny parabola. So I should make sure you understand this. The coefficient of x squared will tell you the way the parabola open up or down. Not only it will tell you how wide, how fat the parabola is going to be. So for x squared, it's somewhere average, okay, not too big, not too small. When the coefficient of x squared getting smaller, you will have wider or fatter parabola. When the coefficient of x squared increasing, you will have a thin or skinny parabola. Okay, and apply for when it's negative as well. Okay, when it's negative, you have this side flipped. When this one negative, it's still this wide, but it's flipped. When you have negative here, it's still same shape, but it's flipped. Instead of up, it's down. Same here, up or down. Same here, it becomes down. Okay, so keep that in mind. This coefficient of x squared, very important. So the graph of f of x equal x squared is this.